Hello and welcome to our second webinar on connected autonomous vehicles. My name is Peter Taillon. I'm a senior data analyst with the digital think tank of the Information and Communication Technology Council, and I'll be moderating the event. Today we'll be exploring the world of non-passenger CAVs. Over the course of the next hour, we'll hear from a panel of distinguished speakers discussing various topics related to non-passenger connected autonomous vehicles. First, as a bit of housekeeping, let me point out that you can post questions throughout the event using the chat feature, and our panel will address them during the question and answer session after the presentations. Our event will proceed as follows. First, I'll briefly set the stage for our panelists, and this will give an overview of the state of non-passenger CAVs. Next, we'll hear from our presenters. First, Barry Kirk, CEO of the Canadian Automated Vehicle Centre of Excellence. Uwe Mueller, Program Manager at Volvo Autonomous Solutions, and Martin Abadi with the firm of Borden, Ladner, and Gervais. Each of our speakers will deliver a presentation on a particular aspect of non-passenger CAVs. And following this, we'll have a roundtable discussion with an opportunity to address questions from our audience. So let's get started. Passenger AV and CAVs have often dominated the conversation related to autonomous transportation. It's an evocative technology bringing to mind many incredible images with the potential for unprecedented social impact. Passenger CAV technology has the potential to drastically improve the safety of travel. It can lead to more effective use of public transportation, and combined with electric vehicle technologies, can vastly improve our urban environment. The impact of passenger CAVs would be felt through an entire social ecosystem, creating a myriad of improvements and efficiencies. These would be felt in areas such as law enforcement, where we would see less demand on law enforcement resources, healthcare, where we would see reduced pressure on hospitals and frontline workers, not to mention easier access to healthcare. And people would see more flexibility in choice of modes of transportation, and so on. In many ways, autonomous passenger transportation has an almost science fiction-like mystique to it. But in reality, there remain incredible hurdles to be overcome before passenger CAVs become commonplace. So within cities, where arguably the biggest impact is going to be felt, the urban infrastructure needs to be updated and engineered to support CAVs. And once the technological challenges are surmounted, deploying the vehicles requires extensive policy and legislation to be put into place. Finally, and most importantly, people will need to feel comfortable with this new technology being part of everyday life. So a sense of trust in CAVs still eludes popular perception, despite the attempts to sell the upside. Many automotive industry experts are conceding widespread adoption of passenger CAVs has stalled. No pun intended. Now, we might argue the baby steps towards acceptance will first come through non-passenger CAV breakthroughs, and in this domain, there's much potential and many success stories. For example, one such step is that of truck platooning. So this is a system where a transport truck driven by a human driver leads a group of closely following driverless trucks. Test runs on public highways of this sort of approach have met with significant success. But autonomy is not limited to freight transportation. Autonomous trucks are seeing extensive use in mining operations. Automated snowplows are being tested at the airport in Winnipeg, Manitoba. And in other sectors, for example, smart agriculture, autonomous vehicles are playing a key role in crop management. So at this point, we'll now turn to our notable panelists to help us navigate this domain of autonomous vehicles. Again, no pun intended. Our first speaker is Barry Kirk, Executive Director of CAFTO, and his talk is entitled Canadian Ecosystem for Non-Passenger Automated Vehicles. So Barry, before you begin, maybe you could just give us a little bit of your background in the area and your experience.
The prologue there, and let me just talk for a minute or two. And first of all, good morning, good afternoon to everybody. CAFTO is a consulting company. It used to be called, as Peter said, the Canadian Automated Vehicles Centre of Excellence. We and others found that too much of a mouthful, so we're now officially CAFTO. And we ourselves do not develop the technology. Instead, we advise corporations and governments at all levels on how to prepare for the CAV era. Wide variety of clients, both within Canada and outside. I won't go through all of these. We also operate a speakers bureau, and pre-COVID, we were quite busy on providing presentations and keynotes at many different conferences in Canada and outside of the country. Taking off from what Peter just said, I've got two key messages for all of you this morning. The first is that there's a wide variety of non-passenger use cases. And, I want to, in the next 10 minutes or so, these. The second message is that the non-passenger side of the CAV ecosystem will take off and move into volume deployment more quickly than the passenger side. And I'll come back to that later on. So on this slide, these are the different categories of non-passenger CAVs. And I want to show you some examples of each of these. This is an interesting one. A British company called Origo that has a footprint here in Ottawa has developed passenger pods, but they've adapted the technology as an automated dolly. And this is a pilot at Heathrow Airport in London. So that can in fact take the cargo pods between the warehouse and the planes themselves. And this is working very well. And in some ways, many of these non-passenger applications are easier to deploy because you don't have people in the way, you don't have dogs, and it's a far more controlled environment, just like this. On the other hand, you have to be careful you don't hit the plane, because there's been a lot of mention about truck platooning. This is a photo of a demonstration, a trial conducted at a test site in Blainville, Quebec. 3 trucks there, and only the first one has a driver. Local delivery is an important part of the mix. And this is a photo from Ford that shows 2 things in parallel. First of all, a future autonomous truck van for delivering vehicles to the neighborhood. There's also a lot of work going on in Android type robots, as you see here, that could take the parcel out of the van and deliver it to the front door. Boston Robotics especially is doing a lot of excellent work in this neighbor. It may seem futuristic, but it's coming a lot closer more quickly than most people think. You'll also see sidewalk delivery robots like this one from a company called Dispatch, and that's going to be more of those in the future. And this is another one called Jeffrey from Tiny Mile, doing a lot of excellent work. It's a Canadian startup. This particular one is for delivery to local neighborhoods, and this unit is remote controlled and not yet autonomous, but obviously the vision is to move towards autonomy. And in certain parts of Toronto, Jeffrey and his brothers are very well known. A different version of local delivery is a drone. UPS, as you can see here, has done a pilot using not only one of their vans, but if you look above the van, you'll see the drone. And when the van arrives in the neighborhood, the roof literally slides open, the drone lifts off and delivers a parcel to a business or to a front door, and then returns to the van. And even if the the van moves to a different location, the drone can track the van and return to the mothership. To create an ecosystem, one of CAFTO's sister companies is called CASPI, the Canadian Automated Snowplow Initiative. We're going to be doing a number of different things. It's a new company, a new association this year. One of the key things we've done is a student snowplow competition. And the orange machine on the left is the winning entry from the Carleton University team. And we held a competition in Ottawa in May, which means there's no snow, but we used garden mulch, and that worked very, very well. We had a similar competition this year, but we got as far as the technical report, and the team from Laval won, but we had to cancel the physical competition, obviously, because of COVID. Another startup is called Top Hat Robotics, based in Kitchener-Waterloo. And they've developed a machine to do sidewalk inspections. You see it here, and they've been doing a pilot project in Erin, and it can check the physical condition of the sidewalk, and even check for things like a lip, where you've got a jump between one piece of concrete and another. A very excellent project. I'm really pleased with that. Not to be confused with Top Hat Robotics, there's another company called Left Hand Robotics, and they have built a semi-autonomous snowplow for trails and sidewalks, and they've been running a pilot project in Grand Prairie, Alberta. Left Hand Robotics is based down in the States. And on a much bigger scale, Komatsu has launched this monster truck, a heavy hauler, and it was designed from the ground up to be completely autonomous. You can see there's no cab at all, and it runs completely autonomously. And Komatsu have a vision to have in the future a fully autonomous mine. You just load the software in the morning, and the whole mine runs itself. Another Canadian success story is called DOT, D-O-T. You can see it on the image there. And they have developed and redesigned farm equipment to be fully automated. And this company, disclosure, they're a client of ours, at least they were a client of ours. They've been so successful, they were bought out by a US company called Raven, which is bittersweet. I'm really pleased that this Canadian technology was so attractive to Raven, but I'm disappointed that they ended up moving to the States. Construction, Global Industries, a fully automated bulldozer there. The bottom line here is that there's a wide range of use cases, and we can, in fact, in this sector of the ecosystem, leverage the synergies with what's happening on connectivity, of course. So the same basic technology platform, but designed and optimized for a different use case. And the reason I said earlier, I would not be surprised to see non-passenger CAVs beat passenger CAVs to broad deployment, is it started. Some of the ones I've shown you earlier are in commercial use now. And also there's a strong business case. And that's been shown in a number of different segments of this sector. And these machines are generally at low speed, and therefore you get acceptance by the public far better than you would otherwise do. And finally, I want to mention a couple of upcoming webinars in this area. For those of you who are interested, next week there's a webinar organized by the Ontario Good Roads Association on managing winter operations. I'll be speaking and doing a deeper dive into automated snowplows. And later on, November, December, the CAF Canada conference this year will be virtual, and there's going to be 3 sets of webinars addressing a variety of different aspects to CAF technology. And you can see in the bottom right there that CAFTO, as usual, is involved in that. And this is my my coordinates. We also, in the second bullet, we publish a free monthly newsletter called CAV Update. And we aim each month to have about 50% Canadian news and 50% international. And if you want to subscribe to it, as I said, no charge, either write to me directly at the address or to the address on the bottom line there. So that's what I want to say, Peter. And I look forward to answering your questions later on in this webinar. But for now, Peter, back to you.
That's great, Barry. Thanks ever so much for this wonderful overview. Our next speaker is Uwe Mueller of Volvo Autonomous Solutions, and his presentation is From Proof of Concept to Industrialization of an Autonomous Transport Solution. Thanks for joining us, Uwe, and please tell us a little bit about your background and experience.
Yes, thanks a lot, Peter, and good morning, good afternoon, everybody. Thanks for giving us also a little bit the opportunity here to give some industrial insight, so to say. And what I want to show you today is really a little bit a journey where we are kind of in the middle of at Volvo to bring really something that had been, I would say, an idea of some crazy engineers some years ago. We brought that all the way to a full proof of concept with a customer in Sweden. And now we're really on the journey to industrialize that and hopefully bringing that to the market in the close future, so to say. So with that, I want to start giving you a quick overview of who we are. So what is Volvo Autonomous Solutions? It's a pretty new business area that we started within the Volvo Group, and that was just started beginning of this year. And the main aim here is to really accelerate the development, but also commercialization and sales of autonomous transport solutions. And that really kind of as a complement to the Volvo Group's offer of all the products, vehicles, services, and machines we have today. So with that, and why autonomous solutions? Why do we really focus there? I think one thing is that we have seen a lot of activities across the Volvo Group around automation, and we really felt that if we can, so to say, bring all those activities together and also join, so to say, the forces that we have internally, we can be better and also faster and can really get into the market in a much quicker way. Then the drivers for that is for sure that we believe that automation can help us a lot on improving safety, and that's also what you heard earlier here from Barry. There's quite some potential on the safety side, and specifically on the construction equipment sector, it's simply also about removing persons from dangerous areas. Then the next thing is about energy efficiency, and here we also see that automation can be an enabler together with other kind of technical solutions like electrification and connectivity, and altogether that can really boost energy efficiency, and then last but not least, productivity. And here it's more not only on a single machine, it's really about process productivity. So that means really if you have a complete fleet of machines running around autonomously, transporting your material, transporting your goods, the automation part can really boost the overall process productivity for this. And to start with, also we said we need to focus on something to get speed and to get traction. And here that's where we kind of selected or pre-selected some specific segments. And here we really focus on large volumes of goods or material that will be transported on predefined routes in a repetitive flow. And that's really where we want to start and then grow over time into other segments, into other activities, and also into other use cases. But it's not only about, so to say, what's the positive side. There's for sure also some challenges, and I think we heard a little bit about that earlier, and I think in the following speak after me, we'll also hear a little bit on my first item here, and that's really standardization, rules and regulations. So really, what's the legal perspective here? And what we're seeing today is for sure that technical development is most probably happening faster than standardization and legislation can follow. So that's also something that we believe we as an OEM, but also together with our customers, our suppliers and partners, have to manage in a way, because we still have to kind of act in a legal environment which is still developing. So that means also that we need to be flexible in our development and commercialization plans, that we can react to legal constraints and demands, and also standardization that's currently happening. Next thing then, for sure, talking about automation is always the social acceptance part, because we know usually automation is quite often also going hand in hand with kind of replacing human operators on specific tasks. So with that, we also have to work with the complete value chain to understand what's the impact there. But more than only replacing operators, it's also that we will need complete new competences to run and operate those future systems. So that's really a change management journey that we believe kind of the complete industry will be pulled into, and that's something that we have to work together on. And last but not least, if we talk about automation, we normally naturally talk also about connectivity, because that's kind of one of the key stones that automation is built upon. And with that, so to say, cyber security will be of growing importance. So that's also a key focus area where we have to develop and to grow into, to secure also that from a communication cybersecurity perspective, the autonomous solutions of the future will be safe. And with all this, so to say, is a little bit of background, we on autonomous solutions within the Volvo Group will focus on different segments, so to say. So one segment is what we call mining quarries and industrial material handling electric. So that's kind of that segment area where we really want to go in with autonomous, but also at the same time electric solutions. Next to the mining and quarries with a classical machine setup or a vehicle setup, like on the picture you see on the lower right. So those two are kind of connected from a use case perspective, but then the energy source and the machines or vehicles that do the autonomous solution, so to say, or will build up the autonomous solutions, change mainly. Then the next step, and also going into a little bit more different and also maybe more complex use case, because you go out from very confined areas into semi-confined and partly also public. It's then the area of ports and logistics centers, where we see a huge potential. And then the next step, going a little bit further even, or really then on the trucking side and public transport, is really and that's really what I want to share here today. And that's also what the title said, really coming from a proof of concept towards industrialization. What you see in the picture here was really a research project that we had done within Volvo Construction Equipment some years ago. It was a project that started 2016 and went all the way up to 2018, where we demonstrated this first version of a battery electric load carrier in a quarry in Gothenburg. For the autonomous machines, but also for the manual machines that collaborated with those autonomous machines. We had a really continuous production follow-up. We have highly optimized operations. We have much reduced maintenance, mainly due to the electrification, but also to the better usage through automation of the equipment. We have a much better understanding of the production. And also worth mentioning here, we have done this project and proof of concept together and very closely together from the beginning with the customer. So that means we really connected, so to say, machine and technology knowledge, which was coming from our side, with the application knowledge of the customer. And that was for us also a key success factor to doing a proof of concept and showing that this works. And now we're really on the journey to industrialize this autonomous electric transport solution. And it's more than changing just the color of a prototype machine, going more to an industrialized version. This is just the base machine. So to commercialize that and really create a commercial offer for our customers, this is much more than just changing the color of that base machine. It's really to develop and deliver and certify, so to say, a complete solution. And in this complete solution, you also see here that the base machine, that's only one little component in the complete solution. This base machine, so to say, then need the virtual driver, the automation system, which is running in a control tower, so to say, to survey and manage the complete site. This goes hand in hand with all the infrastructure you need on site, and this infrastructure can be for communication, can be for safety, and it can also be like charging stations for the electrical drivetrain to charge the machines. All this together then comes with an operational setup that is really tailor-made towards the customer and the customer's use case. This then goes hand in hand with a new setup of repair and maintenance, because now in this setup, it's not only about servicing and maintaining a standard machine, it's about also servicing, maintaining a complete solution, which in this case is even running an IT system in the backbone. And all this together then also will come, as we believe, new financial setups, new business models, new solutions, where we are really kind of moving away from a classical transactional sales more towards a service agreement with the customer, where we really sell transport as a service towards the customer. And that is then with a tailor-made solution for the customer. And this will, again, as mentioned, consist of several key components. Worth mentioning here, it's really the different communication setup, which could be Wi-Fi, could be LTE 4G, could be 5G in the future. Then we have for sure the base machines, but we also have the infrastructure for connectivity. And also here, what you see on the pictures on the right is the charging interface for the machines. So all this needs to work together. And then last but not least, but still most important for us, is also it needs to be safe. And here's really a clear statement, which is valid for the complete Volvo group, not only for the autonomous solutions part. Safety is one of our core values, and we will never compromise on safety. And that's, for example, in a classical quarry environment, the safety setup will consist of several different kind of levels. First level can be physical separation using barriers and fences that really, in the first step, separates the autonomous part of the operation from the rest. Then there's going to be a dedicated emergency stop solution, which also runs on a certified system. And that is even going that far that if one machine of the autonomous part loses connection to that system, that machine stops immediately. Then going a little bit deeper into the automation functionality, we have the traffic control that is constantly, so to say, surveilling all the machines. We know where the machines are. We know how they interact with each other. So that gives another level of safety. And then the last level of safety here is also that we have an active obstacle detection on the machines based on LiDAR and radar, where we can also then secure that the machines itself can see obstacles and then act accordingly, so to say. So with all of that, I think my main message is that automation is a technical part that will open up for complete new solutions, which will, I think, change the way we're working and also change our offer. And that's something that we believe we have to do all together to be successful. But we're on it, and it's an exciting journey. And I'm looking forward to your questions, and I give it back to Peter.
That's excellent. Thank you, Uwe. Very, very, very interesting. Just to see that large-scale deployment was quite incredible. Our next speaker is Martin Abadi. He's counsel with BLG, and his talk is entitled Legal Considerations for Industrial Uses of Autonomous Vehicles. Now, Martin is going to be connecting to us through traditional cell phone rather than connecting through the platform. So we may encounter a few audio problems, but please bear with us. Martin's a member of the BLG AV group, and his practice specifically comprises regulatory compliance and risk management of automation, robotics, and driverless vehicles, including industrial applications of these technologies. So he's perfectly suited for our discussion. And Martin, I'll pass it on to you.
Thank you very much, Peter. Hope everybody can hear me well.
Yep.
Good morning, good afternoon. As Peter mentioned, I'm a lawyer. I have a disputes and regulatory practice. One of my specialties is in autonomous transportation and robotics. And I'm part of BLG's Autonomous Vehicle Practice Group, which is the largest in the country. I'm accordingly going to be addressing legal considerations that relate to some of the aspects that both Uwe and Barry covered, specifically Barry's examples and with respect to application of non-passenger cabs. So of all those examples that you've heard, with some very interesting expressions of non-passenger autonomous vehicles in applications, be it in mining and construction, in farming, sidewalk robotics that you've heard, the common considerations from a legal point of view that apply to all of these as the characterization of these as motor vehicles. Are they or are they not? And if so, then there is an additional layer that applies to it in terms of the degree of autonomy that this equipment, to use that term, would have. There's additionally two separate, distinct regulatory considerations. One is obviously at the, as I mentioned, at the federal level. The other one is at the provincial, and that applies to all of these. Part of it is, as I referred to on the regulatory side, certification, safety, and licensing, of course. And then there is something other than the regulatory part, which is what I refer to as exposure to determinations of liability. And that might be your ordinary civil liability with respect to the products themselves, which gives rise to product liability considerations, personal injury, and in the case of any type of connected autonomous vehicle, privacy and cybersecurity. Let me start with as we move to the next slide, with the definition of a motor vehicle. What are the equipment is a motor vehicle? That's a threshold issue, and that's at the federal level. There are two separate layers of regulation, as I mentioned. Well, perhaps an additional one, but the main ones are federal and provincial. There's also a residual municipal layer of regulation. But what are the equipment as a motor vehicle is key in the circumstances. And the definition of a vehicle is very broad. It means essentially any vehicle that's capable of being driven or drawn on roads by any means other than muscular power exclusively. Okay, and there's a few other things that are defined in it. So that captures many things. There are classes of non-regulated vehicles that are exempt from what would otherwise be the Motor Vehicle Safety Act, stringent requirements for certification for Canadian motor vehicle safety standards, etc. And those exemptions are based on the particular design characteristics of the vehicle. Specifically, vehicles designed exclusively for off-road use, such as the examples that Barry gave and the examples that Uwe as well gave, construction equipment, utility vehicles, forklifts, skid steer front end loaders, that sort of thing, excavators, mobile cranes. A lot of them are considered non-regulated vehicles. And so there's also a category of work vehicle, which is a vehicle that is usually considered to be designed primarily for the performance of work and the construction of works of civil engineering and maintenance. That also is an important part of that definition, but that is usually something that would require it to be, in order to be exempt, would require it to be constructed on something other than a truck chassis or truck type chassis. So then we get into what a truck is really, and that's again a very broad one, because that's a vehicle designed primarily for the transportation of property or special purpose equipment. And then the regulations go into all sorts of exceptions. It doesn't include, for example, chlorine-mounted vehicle, a work vehicle, or a vehicle for special purposes, such as a vehicle that is designed for operation exclusively off-road. So that's the threshold consideration, so to speak. And that falls mainly within the federal ambit, within our Motor Vehicle Safety Act framework and CMVSS, which is Canadian Motor Vehicle Safety Standards. Whether you fall under it or not is also going to dictate whether a notice of defect has to be issued with respect to any defects in the equipment, which is our way of addressing what in the U.S. would be addressed as recalls more characteristically. So that's again a function of whether this is the equipment in question is a motor vehicle or not, and the answer is in some cases quite clear, in others not so much. As we move on to the next slide, you'll see provincial considerations as well. So as I mentioned, at the federal level, think of it as certifications. Think of it as the manufacturing of the design of a particular vehicle, the safety standards that go into it. At the provincial level, what you have is operation, licensing, registration, insurance aspects of it. So with these non-passenger cabs, one of the questions that arises is, are these, aside from being motor vehicles, okay, which may or may not be the case for some, it depends, it's on a case-by-case basis. That's the approach that Transport Canada, the main federal regulator, takes with respect to the characterization of equipment as a motor vehicle. Aside from that, once you've determined that at the federal level, you also have to ask yourself for provincial purposes whether it is under our local highway traffic acts, whether this is something that is a motor vehicle or not. And if so, whether it's a commercial motor vehicle, a CMV. And in that case, who's the operator? That's important because there is a whole liability regime that is called by and related to the identity of the operator. Sometimes is the operator an individual? Sometimes the operator is an entity in the case of a fleet, for example, and sometimes the operator might be the software. So Barry mentioned platooning as well. That's, and I'll cover that as a bit in greater detail, but that's a part of a pilot program in Ontario, one of the few provinces to have a pilot program with respect to the public road use of autonomous vehicles, and platooning is one of those examples and recent amendments to the pilot program in Ontario. As we move on to the next slide, you'll see the municipal considerations. I call these the residual considerations. These are, think of it as sidewalk issues. And Barry mentioned the top hat robotics example and others in it. And as you can see, those are sidewalk used by non-passenger cabs. So that's, and then there's examples with respect to snow removal, that's a good example of that is in recently Manitoba. You've seen a program in that regard. You have delivery robots, vehicles. The question is, when using a particular sidewalk, there is also an additional layer of regulation as to who's permitted to use it, who's not. So we move on to the next slide here. This is the platooning program, specifically the regulation that was modified. This came into place at the beginning of last year, and what it does, and we had it a brand new update as well, and the beginning of this year prior to the pandemic. And what it is synchronized acceleration, braking, steering for a fleet of trucks, mostly. That couple of interesting issues from a regulatory point of view is the application, or the suspension, I should say, of provincial rules and regulations with respect to the operation of vehicles, say, follow too closely. So there's an exception to that if you're platooning for obvious reasons. Distracted driving, there is an exception for that because to the extent that there is a particular operator operating something that is at level 4 or 5 autonomy, meaning at the highest levels of autonomy without driver intervention. So there are carve-outs for things like that, and I wanted to illustrate the practical aspects. And then we go into the crux of the matter, which is the liability considerations in this slide, the next slide that you can see there. And that's, if I had to break it down conceptually, I would say two aspects of it. One is something that can go wrong with your product itself if you're the manufacturer, and that's the product liability regime in Canada. And in a nutshell, what it is exposure to determinations of liability on two aspects. One, it could be on warranties, which are statutory or contractual with respect to the product, and the other one is with respect to tort, which is a legal term that applies to issues of negligent manufacture, negligent design, or failure to warrant. And that's the type of exposure you have when you have these particular products interacting out there in autonomous fashion. Think of it as risks of having a particular robot operating on a sidewalk, for example, be that salting or removing snow. And then, of course, you can have a malfunction with respect to the equipment that leads to an incident, or you can have good old-fashioned personal injury if the particular equipment does not or provides a particular task in a way that then leads to a slip and fall, say, for example, in an assaulting incident. And then you have cybersecurity risks, which is whether passenger or non-passenger in autonomous vehicles, you're always going to have the issue of the data being hackable, which complicates the liability regime. And you have contractual aspects of it, in meaning the allocation of risk in these contracts. And when that the whole point of this equipment, or many of these, is to provide services to other parties through these applications. And that's, as Barry says, one of the reasons why these applications tend to be more readily acceptable, so to speak. It's you don't see them necessarily on public roads, that you may see them more on sidewalks, etc. And finally, you have the insurance aspects in there, which is something that needs to be addressed as well by entities putting these products, or this equipment, to use that term, in the stream of commerce. Because sometimes the insurance product doesn't exist for this particular type of issue. And I see this often in my practice, where many of the matters I deal with are matters that come referred to me by either brokers or insurers that are seeking to have products that cover these sorts of risks, and are asking about, obviously, the legal regime that governs these. So it's something that obviously has to be addressed, and it's very nuanced and very specific to this particular area. And as the next slide will show, it's a summary of the liability risks. One is class actions, and in product liability cases, particularly, you have class action treatment. It's an issue that can be extrapolated. The defect in a product, if it exists, be that in manufacture or design, is something that can be extrapolated to all those that have acquired the product or are using the particular product, or end users or intended users of the product. So I have in the slide a reference to big data, big liability, big classes, and that's something we've seen, and it started to occur, especially in the US and more recently with on this side. But you have the cybersecurity and privacy issues, the product liability issues, and those give rise to commonalities. Finally, the last slide here is one about trends that I see for non-passenger cabs to watch for next year. Obviously, the pandemic has changed the way we approach autonomous vehicles in general, particularly when it comes to the commercial application of them for non-passenger industrial uses of autonomous vehicles. That is something that I have seen in my practice accelerate. A lot of projects that were on hold during the pandemic became very urgent projects with very tight timeframes and deadlines, because people wanted to have these in place already, given physical distancing regimes, etc. So that's something that it has obviously been affected in a distinct way by COVID-19 and its effect on it. And I have it on the side as rethinking essential services. It's not just at the municipal level, which existed prior to the pandemic, but just in general. And you'll see, obviously, cross-border regulatory initiatives for a lot of the OEMs and manufacturers of these, and that are obviously motivated to have this and lobbying for it. Increased provincial regulation. We have already the platooning program in Ontario, and you'll see more of that coming. There's a whole shuttle program coming into place as well. There's already one in Quebec. And on the data and security, of course, this continues to be one of the concerns. We'll have more federal regulation guidelines. One of the issues is precisely on the definition of a motor vehicle. You wouldn't believe how many cases are referred to me in terms of the determination of what a motor vehicle is for the purposes of AVs and particular classes of regulated vehicles. And an increased provincial regulation, of course, as I said, is something we should see. But at the same time, when I say that, I don't necessarily mean that it's an impediment to it. You will see perhaps programs opening up to it. Ontario has been at the forefront of this, one of the first ones in North America to do this. So that's essentially it. I welcome questions, obviously, on this. I'm sure you have several, but I'm happy to give you a glimpse of what is the salient features, the general outline from a legal point of view as to what we encounter.
Excellent. Thanks ever so much, Martin. That was a great overview. I think it's a side that often people sort of get swept up in the excitement of AV and non-passenger CAV and don't realize, of course, there's a real world infrastructure that this has to operate in. At this point, we'll now turn to some questions that had come up in our chat session. And this will give us an opportunity to explore other areas beyond some of our discussion. And one of the questions that has come up is if we imagine an autonomous non-passenger CAV readiness index, so we've seen those sorts of things, how would Canada compare to other countries? So I don't know, Barry, would you like to step in on that?
Okay. When I look at the overall non-passenger CAV ecosystem, I think there are two components to it. One is indeed, as you said, Peter, and as the question said, preparedness. The other is innovation. I think we're doing a lot of great work on the innovation side of cybersecurity, but in terms of preparedness, I would say we are starting to get there. I think some other countries are doing better than we are, and others worse. I think we're roughly in the middle of the pack. I would put Canada. I would love to see us do a lot more. I know some of the European countries are more active in this area. I think the examples I gave shows that there is interest. One organization I did not mention is the City of Toronto. And, I am allowed to say that, we're doing some work for them at the moment on non-passenger CAVs for sidewalk snow clearing, winter maintenance. So bottom line, I would say the middle of the pack. And I really want to see us do a lot more in terms of preparedness over the next 2 to 3 years.
Uwe, would you be able to comment on, for example, some of the European countries?
Yeah, I think Barry hit it good on the point there, that I think the interest is growing everywhere, definitely. And I see that as well. It's the same in Europe. I think there's some countries that are pushing a bit harder than others. Some are more focusing on electrification, more the sustainability aspects, the others more on automation. I think what I can see so far, and also on an interest level, I think Canada is even beyond some countries in Germany. I think you're more open. I think there's a more open discussion on all levels, which I think is really positive. I think also you have a better discussion ongoing on the legal side, so that, so to say, the legislation is more into the discussions. I think in Europe, there are some countries like Germany, France, they have now started giving, so to say, testing approvals, the same in Switzerland. I think it's coming, but like Barry says, I think we can all do more, definitely.
Mm-hmm. And Martin, in terms of the legislation, would you be able to comment on what would be a similar worldwide index? We understand that there's a lot of activity going on in Canada, as you mentioned, but are there any countries in particular that seem to be flagships of what would be that type of work?
That's a good point. I have followed this closely when it comes to AVs in general and then industrial application of it. I think Canada is quite at the forefront from a regulatory point of view. I recently had the privilege of providing input to Transport Canada on the development of regulations in with respect to particular classes of autonomous vehicles, and that's one of the issues that arose there was that the manufacturers, the technology providers, so to speak, said, "Well, we have the technology, we're ready. We this is all in place, and some of them are being used." So it was it's the laws and regulations that are the ones that need to be developed further and to accommodate this. And a regulator's point of view is like, well, the laws and regulations are there. It's just it's a few tweaks and adjustments that need to be made as whether the technology is ready. It's quite interesting to see that. Overall, though, I would say that having worked with the MTO, with Transport Canada, I can tell you that we are at a high readiness level when it comes particularly industrial application of cabs, absolutely, and even passenger cabs. I think that the example of Ontario is remarkable. Quebec is another one, and it leads. And with respect to the rest of the world, legally, I think Germany has probably the most advanced expression of regulation when it comes to autonomous vehicles generally. I'm not just speaking about non-passenger industrial applications. And so that law is, I think, subject to review shortly, or it has come up. And in it has quite interesting definitions of who the operator is and the allocation of responsibility as between manufacturers, software providers, and drivers, and who's ultimately responsible when you have individuals, humans operating it, so to speak, even if it's in fully autonomous mode. So the short answer to it is, around the world, I think we see that the regulations have caught up with technology. I think that in Canada we're doing quite well. There's still obviously a lot to be done, and if the Ontario pilot project is anything to look at as a standard, I could say it's a very good one.
Okay, excellent. So another question. This looks to be more about technology transfer. So the idea would be, what would be technological breakthroughs in non-passenger CAVs that you think would most push ahead passenger CAV, either safety or adoption, or just sort of general technical advancements? So Uwe, let's see. Could you comment on that?
It's a good question, but I would say it goes in both directions. I'm not sure if really the non-passenger CAVs will push a lot technology into the others, but I think they will enable the understanding much better, because I think they can also start on simpler use cases, which makes it easier to start, get going, grow from there, grow functionality. So don't go for the big bang right from the beginning. And I think it will help a lot, both the technology companies to kind of grow, build competence, but also on the application side, build trust in the solutions. I think that's even more important than the technical aspect.
Mm-hmm. Yeah, certainly. Barry, did you have something you'd like to add to that?
Definitely, Peter. One thing that my colleagues there, Uwe and Martin, have both mentioned are standards. And I want to give a shout out to Bernd Grusch, who some of you may know, based in Toronto. He is leading a global project to develop a new standard called ISO 4448 for managing automated traffic on sidewalks. And basically, the vision is to set up an air traffic control type system, not to remote control, but to allow automated vehicles to both cross the sidewalk from a vehicle to a building, to go along the sidewalk, and to respect the fact that there's going to be people, kids, dogs, pop-up patios, as we've seen this year, disabled people in wheelchairs. It's a complicated job, and it's going to be a multi-year process, maybe 3 years, maybe longer. And I think, to go back to the question that you passed along there, Peter, this effort seems to be being led on the non-passenger side, but if we can set up an air traffic control type system on the sidewalk, that could be a very good pilot case to allow some degree, high level control of passenger vehicles on our roads, which would lead to greater efficiencies and hopefully greater safety.
Excellent. There's a question here. Do you see future legal tech that specializes in the CAV realm of law? So obviously this one was for Martin. So I can kind of see that thinking, because there's legal tech related to patent law. There's all sorts of software that's been developed in that area. Wills and estates is another one. Can you see some area where either AI can be used for helping with this sort of analysis, Martin?
Sorry, is the question, do we have the software to do my job? Is that it?
Well, yeah, I guess you could put it that way.
The answer is no, absolutely not. There never will be. No, that's it. No, I think it's an interesting question because it raises the prospect as to whether there is something fundamentally reducible to algorithms in terms of how you approach the analysis of AVs and CMVs from a legal point of view. And I think that there is, being, as I said, one of my specialties being in autonomous transportation and robotics and technology, I see these efficiencies being applied. I think that ultimately, in any ambit where you're applying general principles to immediate circumstances, being able to, and I deliberately categorize it as broadly, right? General principles to immediate circumstances, you need to be able to discern what the relevant principles are, reduce those principles, and then identify the circumstances and apply them. It's in a way, it can reduce itself to binary logic, which is really what AI and other software uses. So it's, but there is obviously an art to it, and that's the difficult part. So, but to tie it in with a very good question that was posed before in terms of what we learned from industrial application AVs for passenger AVs, I think that you see this, and you'll see a lot more spillover, so to speak, because one of the reasons that I think that industrial application of AVs is so successful compared to passenger ones is because you don't have to deal with all the contingent scenarios of the human condition, as on pedestrians, bicycles, etc., all sorts of things. It's you have a very restricted area, a very narrow realm, a very narrow set of operations and scope of operations and tasks, and a lot of things, and you can take a lot of risks that normally you wouldn't take. Now, the sidewalk is an interesting example once you bring it in there. And that ties in as to trial and error, so to speak. It's something that you can afford to do perhaps in more restricted environments where there isn't passenger traffic, so to speak. The sidewalk gets a bit tricky because that's the whole point of it, is that you're going to have passenger traffic. But you learn from the, as I said, from the trial and error of it. And to tie it into the question you just posed, yeah, you'll as we progress, we'll be able to learn more about how to apply that to a variety of areas and disciplines, including the law, and how we analyze or examine the various regulations that apply to AVs, for example.
Mm-hmm. Excellent. That's great. Thanks. Well, at this point, I'm going to need to bring the event to a close. So we'll be sending out answers to any of the questions we didn't have time to address in a follow-up email. And at this point, I'd like to thank basically our speakers, of course, for taking the time out to share their insights and their expertise. Also, Satna, Tyler, and Fawn, who are working behind the scenes with ICTC. And a big thank you, of course, to everyone that tuned in. So we appreciate your comments and your participation. If you would like to reach out to anyone who was part of the production team or any of our speakers, you can get in touch at these email addresses. And at this point, again, I'd like to thank you all for attending, and I wish you all the best. And thanks ever so much for being part of our event today.
And thank you, Peter, and goodbye, everybody.
Thank you. Bye-bye.
Thanks, guys.
Thank you, everyone.